Welcome to solverfy.
So we have to estimate the acceleration due to gravity on Europa's surface, one of Jupiter's moons. So we can say that let's say that subscript 1 denotes Europa, and we can say subscript 2 denotes Earth. So to estimate the acceleration of gravity on Europa's surface due to the information that we already know from Earth, we can start off by saying that the density of Europa is approximately equal to the density of Earth. So P sub 1, rather rho sub 1 equals rho sub 2. And we can further define this and say that the mass of Europa divided by 4/3 pi r sub 1 cubed is going to be equal to the mass of Earth divided by 4/3 pi r sub 2 cubed. So this is essentially saying that for the definition of density, a mass divided by the volume, and we're going to model Europa and we're going to model Earth as perfect spheres. So we can say that r sub 1 is going to be equal to r sub 2 times m sub 1 divided by m sub 2 to the 1/3 power. So the radius of Europa equals the radius of Earth times the cubed root of the mass of Europa divided by the mass of Earth. And so at this point, we can say that the gravitational pull on Europa is equal to the gravitational constant times the mass of Europa divided by the radius of Europa squared. We can say that this is equaling gm sub 1. Now we're going to substitute this in for here, and we can say r sub 2 squared m sub 1 divided by m sub 2 to the 2/3 power. And at this point, we can simplify the gravity on Europa's surface would be equal to g m sub 1 to the 1/3 times m sub 2 to the 2/3 divided by. So the gravitational constant times the cubed root of Europa's mass times the cubed root of Earth's mass squared divided by the radius of the Earth squared. This is going to be equal to gm 2 divided by r sub 2 squared times m sub 1. So at this point, we can say that we wanted to factor out these because we can substitute 9.8 for this because we know the gravity on Earth's surface. So essentially, the gravity on Europa's surface will be equal to the gravity on Earth's surface times the mass of the Europa divided by the mass of Earth to the 1/3 power. And at this point, we can solve and say g sub 1 equals 9.80 meters per second squared times 4.9 times 10 to the 22nd kilograms divided by 5.98 times 10 to the 24th kilograms to the 1/3 power. And so we have 1.98 meters per second squared. So this would be the acceleration due to gravity on Europa's surface. That is the end of the solution. Thank you for watching.